Which brings us to a definition of rationality. And I think you can define, or three different ways in which you can define rational behavior are the following. And I've called it the benchmarks of rationality because it's a way of, it's not necessarily a goal we should strive towards. Being completely rational in this way is very contrived and often very time consuming. But it does offer us a benchmark, a measuring tape, as it were, to hold up to what people are saying and deciding and checking whether, if we would expect people to make rational choices, what would it look like? What would it ideal look like? And how do we deviate from that ideal? So it's a benchmark, if it were. And you can define that benchmark in three ways. First way is the logical benchmark. And what we mean by that is that we can check whether people are consistent in the beliefs they express, whether believing one thing is consistent with believing another thing. Another thing is another benchmark is the probabilistic benchmark, which is updating your degree of belief. So to what extent do you think it's likely that the lecture will end in half an hour? And I offer you some new information. How do you update your degree of belief on the basis of new information? And do you update that degree of belief in line with the rules of probability? Most people fail to do so. Most people struggle with reasoning properly using indices of probability, which is also why you're learning statistical reasoning in this course. The third decision benchmark is the third logical benchmark is the third rational benchmark is the rational decision benchmark, which is also deals with consistency, but it's consistency of preference and choice. So if you state a preference or make a choice in a certain way, and you do it again at a later time, is that second choice consistent with your first choice? Or do you show a reversal of preference depending on the circumstances? So what we're going to talk about is, I'm going to give you short examples of the different ways in which we fail to live up to these benchmarks. So I'm going to give you a couple of reasons to believe that people can be considered to be irrational. Starting with the first, the logical benchmark. So if I give you this task, which looks familiar to you because Peter Starreveld probably discussed it with you as well, but I'm betting that he didn't use Pikachu and Justin Bieber, Kanye West and Squirtle, or Pokemon and male American singers as an example. That's why I chose these. It's always safe to do Pokemon because Peter probably didn't use them in his presentation. So let's say we're given a stack of cards, all of which have Pokemon figures on one side and singers on the other side. Test the following rule. If there's a Pikachu on one side, then Justin Bieber will be on the other side. Summarizing, if Pikachu, then Justin Bieber. My question is, which card do you need to flip over to check this rule? Whether the rule is true, whether the rule holds for this stack of cards you're presented with. So Pikachu and Kanye. Rosa, could you elaborate on your answer? Why did you say Pikachu and Kanye?
Sure. Because Pikachu, you have to turn over to make sure that Justin Bieber is on the other side, and Kanye West is to check that you can actually, that there wouldn't be a Pikachu on the other side. So basically, you would have to show, falsifying that there isn't a Pikachu on the other side of Kanye West as well.
Very good. Very good. How did you come to this answer?
Because I read the material of the chapter that you posted and they made similar examples.
That's excellent in itself. So well done. And well done for bringing it up, and well done for illustrating your answer. It's excellent all around. And still, it's not, you don't have to laugh about it because that you read it before. You still have to apply it to a new example. Right? Because the book also didn't talk about Pokemon and Justin Bieber and Kanye West. So you still applied it to a different example in a good way. So you're saying we need to not only verify the rules. So if Pikachu is on one side, Justin Bieber should be on the other side, right? So that's what we're checking by flipping the Pikachu card. You need to also falsify or check the other implication of the rule. Let's say the falsification. So if it says if Pikachu, then Justin Bieber, you have to also check whether if Justin Bieber is not on the other side, that it is indeed also the case that Pikachu isn't on the other side as well. And that's why you flip the Kanye West card, right? If you're saying if P, then Q, the logical consequence of that rule would be if not Q, then not P. That's logically implied by saying if P, then Q. So if you're checking the rule if P, then Q, if Pikachu, then Justin Bieber, you should check both logical implications by flipping Pikachu, but also by checking whether if not Q, then not P holds. If not Justin Bieber, if Kanye West, then not Pikachu, right? If you're a bit worried now about the degree of how abstract it's become, bear with me. This is just the point for now. For today is just showing you how we struggle with following these rules. So what I just illustrated to you and what you perhaps experienced in your head is that it's difficult to follow the rules of logic when reasoning, which is why people say we fail to meet up to that first benchmark of rationality. All right, so it's sometimes easier when the stuff we're talking about in logical rules correspond with how we know the world to be. So if we're not talking about Justin Bieber and Pikachu, but about rain and clouds, and we're saying if it's raining then it's cloudy, that corresponds more by how we know the world to be, because we know that without clouds it cannot be raining. So if not clouds, then not rain, or if not Q, then not P. But for now you can forget this example. We're going to cover it in more detail next week when we're talking about logic on Tuesday. What it does illustrate is one of the reasons why people commit to confirmation bias. We don't really know, and one reason for confirmation bias would be that we don't know what the logical implication is of the stuff that's being claimed. So most people don't consider that they should try to falsify the falsification implication as well of the term being used. Eva saying in the comments, I don't know why I see it right now, you didn't make any statement about squirt. So Eva, for you, I did make a statement about that it's a stack of cards which always have Pokemon on one side and singers on the other side. So that's something to bear in mind, Eva. All right. Again, I shouldn't look at the comments because it's going so quickly. I was just distracted. I'm sorry. All right, so the reason why we make this mistake most often is not necessarily because we are failing as logicians, but mostly because usually when people say this kind of stuff, they imply something. So the conversational implicature leads people to make these logical errors. So if I would say to my daughter, if you don't eat your vegetables, then you get no dessert. And my daughter would say to me, I ate all my vegetables, therefore I get to eat dessert. And I would say, no, you're wrong. Ha, ha, ha. That was not logically implied by what I was saying. I'm just being a mean guy, right? And I'm being a mean guy. You're considering me to be a mean guy because nobody, when saying if you don't eat your vegetables, then no dessert, means strictly only the logical implications of that rule would apply. Usually we also mean that if you do eat your vegetables, then you do get dessert. That's the implication of what we're saying in the conversation that we're having. And because that's usually the implication of what we're saying, then that's the reason why we are confused. If we need to argue about the logic of what's being said, but we rely on a conversational implicature. That's one of the reasons why we fail to live up to that logical benchmark. Another example is depicted above, which is a text from the Bible, clearly the Old Testament. I think so, at least it's talking about a vengeful God, so that I would associate that with the Old Testament. And it's saying what would happen to you if you're, all kinds of bad individuals, right? So if you're fearful or unbelieving or abominable, a murderer or a whoremonger or a sorcerer or idolater, it's a whole list of stuff you shouldn't be, according to this excerpt from the Bible. And you shouldn't be leading your life that way because you will burn for eternity in a lake of fire once you die. So again, conversational implicature applies, because if you say, well, I made sure I'm not a whoremonger, so I won't burn for eternity in a lake of fire, that's not, logically, it's not what's being said in this excerpt from the Bible. But usually that's indeed implied in our conversational rules. All right. Right, so that's conversational implicature is one reason why we're thrown off by logical problems, right? Another reason why we're thrown off by logical problems and we fail to meet that logic rationality benchmark is that we're not very good at focusing on the logical structure of an argument and keeping out our beliefs about the truth value of what's being said. So in the video for the PA of this week, I differentiated between logical assessment and factual assessment. And I said that logical assessment, looking at the structure, so the connection between the premises and the conclusion, should be a separate part of assessment before you look at the factual, whether you believe the statements to be actually true. So you have premises here, like all dogs are animals. Some animals are German Shepherd dogs. Some dogs are German Shepherd dogs. And what we mean by logical analysis is if when I ask you, is this argument valid, what you have to check for is the connection between, P1, P2, and the conclusion. It doesn't involve checking whether you think indeed all dogs are animals, or whether it's true that some animals are German Shepherd dogs, or whether you think it's true that some dogs are German Shepherd dogs. You just have to focus between the connections. Most people fail to check. I keep looking at the comment section. I'm sorry, it's okay. But most people fail to answer this question adequately, which is why we're training you to check for deductive validity as well, starting Tuesday, the lecture next Tuesday. It's easier to see why an argument is valid or not if we use a counterexample. So if I say to you, all bananas are yellow things, some yellow things are skippy balls, therefore it means that some bananas are skippy balls, everyone would agree that that argument isn't valid. So the point for now is, most people have less difficulty seeing that the second example isn't valid than the first example. The reason why they have more difficulty seeing in this German Shepherd dog example why it isn't valid is because the conclusion corresponds with the way they believe the world to be. So you have a belief about the world that it's true for this world that some dogs are German Shepherd dogs. And because you think the conclusion holds, you think that the argument must therefore be valid, which isn't the case. So an argument could have a conclusion that happens to be true, even though bad reasons or reasons are being offered that are not connected to the conclusion or the truth value of the conclusion. For now, it's important, not necessarily the validity, but that we differentiate between the structure, so the logical assessment, and the factual assessment, and the fact that because we have beliefs about the world, we believe the conclusion to be true, that interferes with our logical assessment of the argument. And that confusion we call the belief bias. The fact that stuff you already believe about the world hinder you in looking at the actual structure of an argument that's being offered. That, of course, is all human beings being efficient, right? So if you know the conclusion to be true, why should you check anything else, right? That's not useful in actual daily life in most use cases, just as using conversational implicature is more useful than looking at what are the actual logical implications of the stuff that's being said. So especially as psychologists, you shouldn't have to use a lot of imagination to think why people are reasoning in this actual way and not in a logical way, because this is more efficient in most examples. But it also leads us to trip up if we're asked to reason logically. And that would be the reason that we fail to meet that logical benchmark. So we should strive for falsification, but we engage in confirmation bias. We should consider only relevant information, but we also consider conversational implicature and belief bias, even though it's not relevant in these examples. All right, so that was the first benchmark. Remember, we talked about 3 benchmarks: logical benchmark, probabilistic benchmark, and a rational decision benchmark. We're moving to the probabilistic benchmark, if only because I can show you this excellent example. So this is a person, I don't know what her name is. I think she bought it or she baked it, I guess. And what she baked was is this. This is a grilled cheese sandwich, which supposedly bears a striking resemblance to the Virgin Mary. So that's interesting, right? So, and the question is, could it be a coincidence? So a person bought this eventually on eBay for $26,000. Which is a striking example to me of people being fooled by randomness. So people think that it couldn't be a coincidence that you're making a grilled cheese sandwich and the result shows the face of the Virgin Mary. That couldn't be a coincidence. That must be I don't know, a miracle, right? Or how you call those holy miracles. I think that's the reason why this sold for a lot of money. And if this is not a hoax, the second example I'm going to show you, she did not only sell the grilled cheese sandwich on eBay, but she also tried to sell the pan in which she, the holy pan that made the grilled cheese sandwich. I haven't been able to check whether the second example is a hoax or not, but it's funny, right? People are being fooled by randomness, and by being fooled by randomness, they're willing to pay a lot of money for random stuff. So, another way in which people are being fooled by randomness is that a lot of people seem to think that there's an actual connection between 5G, so the installation of a new telephone network and the coronavirus. So the coronavirus might be caused by the fact that a new telephone or a new internet connection has been implemented all across the country. Could be just coincidence, right? 5G being installed in 2020, coronavirus pandemic in 2020 just happened to be in the same year. It doesn't have to be connected. And indeed, 5G is not the cause of all problems. So we're being fooled by randomness, and we're going to check whether you are being fooled by randomness as well, using a classical example from research by Tversky and Kahneman. So the given is the following case. A certain town is served by 2 hospitals. In the larger hospital, about 45 babies are born each day. In the smaller hospital, about 15 babies are born each day. As you know, about 50% of all babies are boys. However, the exact percentage varies from day to day. Sometimes it may be higher than 50%, sometimes lower. For a period of 1 year, each hospital recorded the days on which more than 60% of the babies born were boys. Which hospital do you think recorded more such days? Is it A, the larger hospital, B, the smaller hospital, C, about the same? All right. Oh, I hate this question. Yeah, it's a familiar question, right? And it's related to probabilistic thinking, to your statistical reasoning skills. B. All right. Let's see. Theresa, could you elaborate on why you chose B?
Generally would expect in that because it's supposed to be 50, right? That it evens each other out. But in a smaller sample, you might not get that because you have variations have a big influence.
Mm-hmm.
I'd say.
Right. Sorry, I had to concentrate because there was an echo in your audio. It has probably something to do with my setup, but it's been a complicated setup. But I thought you were saying because it's a smaller sample, if you given that you got a relatively large deviation from the population mean, I'm paraphrasing here, that's more likely to happen in a smaller than in a larger sample. Right? I think that was the gist of what you were saying. At least that would be an excellent excellent reason for choosing B. That's not what most people do. Most people choose C. They think the probability is about the same in both hospitals. So they fail to account for sample size. And of course, as you're going to learn again with Sharon on Thursday, I think he didn't talk about it yesterday, but he will talk about it next week, that if you take a sample from a population, as the sample size increases, the sample mean will approach the population mean. And that applies here as well. That's what we mean by using a larger hospital versus a smaller hospital, that the sample of the large hospital compared to the whole population of human beings is larger and will probably be closer to that population mean. So given that we find a large deviation from that population mean, it's more likely that it occurred in the smaller sample, the smaller hospital, than in the larger hospital. For now, the details Sharon will get into next week. But for now, this is an intuitive way of using your statistical reasoning skills. So well done, Theresa. All right. Of course, last time we talked about critical thinking. I also gave you another example in which you had to use the same skills, right? So accounting for sample size was something that at least the people on this website that I showed you back then failed to do. they're saying, oh, of course, the statistical differences don't exactly add up, but I'm still seeing a difference between the means between those groups. So basically what they're doing here is ignoring the difference in sample size between the two groups. So again, we're talking about small and large samples. We're talking about small and large hospitals, and we're talking about the small size of the unvaccinated group compared to the vaccinated group here, which you should take into account when making these comparisons. So you should account for sample size. Most people don't, which is what we call sample size neglect, and which is an illustration of people failing to reason according to the lines of probability, which is one example of the ways in which people fail to meet that second benchmark of rationality, which is the probabilistic benchmark. Finally, we're going to talk about the third rational decision, the third benchmark of rationality, which is related to the second one. It's we can check whether people are consistent in their preference and their choice. And spoiler alert, they're not, but I'm going to show you an example of that. So if I would ask you the following, you can buy a lottery ticket. It will cost you $1 for one chance in 1 million of winning $1 million. You could come up with a rational answer to the question, should you buy things? So given that you value money, and given that we're dealing with actual objective probabilities here, since it's a lottery with stated objective probabilities, the question is, should you buy the ticket? And then as a rational thinker, you should be able to calculate the expected value of taking the bet or not taking the bet, or buying the ticket or not buying the ticket. So you could calculate, you have to multiply, according to that rational model, the probability times objective value. So the probability of winning is indicated here, and the objective value of winning is indicated here. And we deduct the price of the ticket, which is $1, which gives us an objective expected value of $0. So your answer as a rational thinker should be, I'm indifferent, right? If I don't buy the ticket, the expected value is 0. If I do buy the ticket, the expected value is 0 as well. Right, so most people don't reason this way, at least not intuitively. And that's one reason why we're perhaps not consistent in our preferences. But another reason is that it's difficult for most choices to get from an objective probability to a subjective expectation. So how likely do you think something is to happen? And to get from an objective value, so a lot of choices you make don't involve dollar values, but something else. Do I feel good or bad about it? And what amount would I feel better in the one case than the other? So what people then talk about when we can talk about objective value is expected utility. So how useful is one outcome compared to the other to you? And utility could be any number you want to assign it. So we can't talk about money because, I mean, most choices yield outcomes that are valued subjectively, but you can assign a certain number to how much you value a certain outcome or not. And if you then reason consistently on the basis of that assignment of utility, then you would still be considered a rational thinker, because your preferences, your choices that you make are in line with maximizing that subjective expected utility. So you're still maximizing that which is important to you, that which you indicated is important to you, which would still make for very convoluted choices, right? So if you go out and you wonder, should I take an umbrella? Then you have to take into account the probability of different outcomes or your expectancy of different outcomes. So how likely do you think it will be raining or not? And what would the subjective experience be to you? What would it feel like to you to go out with an umbrella, but it won't be raining, which is a hassle. So which would make you feel somewhat worse. 30, a utility of 30. It's a random number, but you should be consistent once you've chosen them, assigned them, compared to having an umbrella with you in the case that it rains, which would make you feel good. It would make you even feel better if you don't bring an umbrella and wouldn't rain, right? So that's the maximum outcome according to you. Just an example, right? So how much do you value the different outcomes? Give it different numbers. And then you can multiply the probabilities of stuff happening by the values you assign to those outcomes. And then you can try to choose the option that yields the highest expected utility to you. All right. I mean, you're probably not using this procedure a lot. I mean, if you're considering back in the day when you were actually going to lectures, what should I do? Well, should I stay in late, or be up early, or go to the pub the day before? Then you could take into consideration all types of factors which are important to you: ingesting beer, having sleep, impressing your peers, etc., etc. And you could think to yourself, how do I value those different outcomes? And you could think to yourself, given the different decisions I could make, what would be the expectation of having more or less beer or more or less sleep, depending on which option you choose. I mean, I'm just trying to show you that makes for a very complex process if you were to do this with every decision you make. It's still useful to do it this way if you're making a very important decision, like buying a house, for example. But you would agree with me that most decisions we don't actually do this, which is one reason why we fail to meet that rational benchmark, that rational decision-making benchmark. Another reason is that we're not consistent in our preferences, which was shown by using the Alep paradox. In the Alep paradox, you're giving the following choice. So you have to make a decision twice. The first decision is experiment 1. You have to choose between lottery 1A or lottery 1B. So either 1A, 100% chance of winning $1 million or euros or whatever, or lottery 1B, 89% probability of winning 1 million, 1% probability of winning nothing, 10% probability of winning 5 million. What would you choose? Ah, nice. Natalie says, I would choose 1B because the expected value is higher. Yeah, you're right. And if you were actually offered this choice, in actuality, Natalie, would you still choose 1B?
No, I wouldn't, because I want to be sure. But I think you could earn more if you choose 1B.
Yeah.
The expected value is higher.
Yeah, thanks. So, excellent answer. Excellent that you've calculated the actual expected values. And excellent that you reflect on what would I actually choose. Yeah, most people would choose A, as was what the experiment yielded indeed. And they would choose A because it gives you certainty, right? So we prefer certainty in this case, certainty of winning something. So we're a bit risk averse, you might say, as the original authors concluded here. If I give you a second example, you have to choose between 2A and 2B again. So you have an 89% probability of winning nothing, or 11% probability of winning 1 million, or 90% probability of winning nothing and 10% probability of winning 5 million. What would you choose? All right, I'm seeing a couple of 2Bs here. All right, which would indeed be what most people would be choosing. So why would we call this paradoxical? What is paradoxical is that most people choose A in the first instance, and most people choose B in the second experiment. And that is paradoxical because, as Natalie indicated, in the first experiment, the expected value of B is higher, which is also the case in the second experiment. And that is what it makes it paradoxical. So in the first instance, you could say, well, people choose not to maximize expected value, right? It could be the case that people just don't like getting money, which could be, so let's say you're an alien, right? You landed on planet Earth, you look around you, and you don't know what people like, and you give them these choices and they choose the option that yields them the lowest expected value. So you conclude as an alien, you know nothing about human beings, that they don't value money. That could be your conclusion. But then you do experiment 2, and then indeed they seem to value money, but now they choose the option that has the highest expected value. So if you translate that to that subjective experience, so if we as economists try to distill from people's actual choices what kind of stuff they value, or what is a utility they assign to their different choices, you would say that the option that yields them the least probability of winning money, or the lowest expected value, is more valued by people. But then that seeming preference switches in the second example. That is what makes the paradox paradoxical. Not that people choose that people choose A in the first experiment, but it's paradoxical that they choose A in the first experiment and that they choose B in the second experiment. So their choice in the second experiment, logically speaking, is inconsistent with their choice in the first experiment. Their preference in the second experiment is inconsistent with their preference in the first experiment. And that's why this result is paradoxical. That's why this result shows that we're not abiding by that third benchmark, the rational decision benchmark, showing consistency of preference and choice.